This lecture is on the states of matter, specifically with energy related to phase changes. First, a review about the properties of the three states of matter. Gases have these characteristics. They assume the shape of the container, have an indefinite volume, and are compressible. Liquids have these characteristics. They assume the shape of the container, have a definite volume, and are incompressible. Solids have these characteristics. They have a definite shape and a definite volume, plus are incompressible. Here are two energy diagrams showing the following illustrations. An exothermic system has a higher potential energy on the reactant side than on the product side. The result is that the enthalpy change, or delta H, is negative or less than 0 energy units. An endothermic system has a lower potential energy on the reactant side than on the product side. The result is that the enthalpy change is positive or greater than 0 energy units. Now a discussion on several phase changes involving enthalpy. First is melting and freezing. Melting is a phase change in converting a substance from solid to liquid state. For example, water in the solid state is transformed to water in the liquid state, resulting in the enthalpy change having positive energy units. The opposite of melting is freezing, where it is a phase change in converting a substance from liquid to solid state. For example, water in the liquid state is transformed to water in the solid state, resulting in the enthalpy change having negative energy units. For the melting process, when solid water converts to liquid water, this process is called the enthalpy of fusion, which equals 6.02 kilojoules per mole. The enthalpy of fusion is defined as how much energy is needed to convert 1 mole of substance from solid to liquid state at its melting point at 1 atm. The opposite process of the enthalpy of fusion is the enthalpy of crystallization, which has a negative value of the given heat of fusion value, in which for freezing water it's negative 6.02 kilojoules per mole. The enthalpy of crystallization or solidification is defined as how much energy is needed to convert 1 mole of substance from liquid to solid state at its freezing point at 1 atm. Second is vaporization and condensation. Vaporization is a phase change in converting a substance from liquid to gas state. For example, methanol in the liquid state, when converted to methanol in the gas state, results in the enthalpy change having positive energy units. The opposite of vaporization is condensation, where it is a phase change in converting a substance from gas to liquid state. For example, methanol in the gas state, when transferred to methanol in the liquid state, has an enthalpy change of negative energy units. For the vaporization process, when liquid methanol converts to gaseous methanol, this process is called the enthalpy of vaporization, which equals 35.2 kilojoules per mole. The enthalpy of vaporization is defined as how much energy is needed to convert 1 mole substance from liquid to gas state at its boiling point at 1 atm. The opposite process of the enthalpy of vaporization is the enthalpy of condensation, in which it has a negative value of the given heat of vaporization value, which for condensing methanol is negative 35.2 kilojoules per mole. The enthalpy of condensation is defined as how much energy is needed to convert 1 mole substance from gas to liquid state at its condensation point at 1 atm. Third is sublimation deposition. Sublimation is a phase change in converting a substance from solid to gas phase. For example, carbon dioxide in the solid state, when converted to carbon dioxide in the gas state, results in the enthalpy change having positive energy units. The opposite of sublimation is deposition, where it is a phase change in converting a substance from gas to solid state. For example, carbon dioxide in the gas state is transformed to carbon dioxide in the solid state, where the enthalpy change has negative energy units. For the sublimation process, when solid carbon dioxide converts to gaseous carbon dioxide, this process is called the enthalpy of sublimation, which equals 25.2 kilojoules per mole. The enthalpy of sublimation is defined as how much energy is needed to convert 1 mole of substance from solid to gas state at its sublimation point at 1 atm. The opposite process of the enthalpy of sublimation is the enthalpy of deposition, in which it has a negative value of the given heat of sublimation value, in which carbon dioxide depositing is negative 25.2 kilojoules per mole. The enthalpy of deposition is defined as how much energy is needed to convert 1 mole of substance from gas to solid state at its deposition point at 1 atm. Here is a review question for you to ponder on. Look at each of the key properties and write solid, liquid, or gas next to each statement. A, substance is at 25 degrees Celsius if its boiling point is 58 degrees Celsius. B, substance has strong attractive forces and is incompressible. C, substance has high energy and compressed in size. Pause the video if you'd like to try this problem first, and continue when ready, where the answers will be shown below thereafter.